Hi everyone, welcome back to the video lecture on phase transformation. In the last video, we have seen the difference between the homogeneous nucleation and the heterogeneous nucleation. So what is the main differences between these two? In this video, we are learning about homogeneous nucleation. So two lectures will be continued on homogeneous nucleation. Okay, so next. Phase transformation is related to the thermodynamics parameter called as a free energy. That is G value, Gibbs free energy. The transformation will be spontaneous only when if the free energy change delta G, not a G, it's a delta G, is negative value. Okay, so as I said, the nucleation will be takes place. Homogeneous nucleation will be takes place only when there is delta G value is negative. So what do you mean by this delta G? There is a change in the free energy. That is G2 minus G1. If we consider the molten liquid initially, it is having a Gibbs free energy of G1. That is given by Vs plus Vl into Gv of L. So Vs is the volume of the solid sphere plus Vl is the volume of the liquid. Then delta Gv is the free energies per unit volume of a liquid. I will write it. Volume of solid, Vl is volume of liquid, and delta Gv is free energy of liquid per unit volume, right? So when there is a formation of a small solid inside this liquid, there is a change in the Gibbs free energy to G2. This is given by the equation Vs into Gv of S plus Vl into Gv of L plus ASL to gamma SL. As in the previous equation, we come to know about these two. So this is the interfacial free energy. Solid, liquid, interfacial free energy, right? This is the area of interface, surface area. This is G2 and this is G1. Okay, so difference of these two will give rise to delta G value. So I'll write it, and we will get it as delta G as Vs into delta GV plus ASL into gamma SL. This is because of G2 minus G1 from the previous slide. Okay, this is the that we got, and we know that delta GV, this equals to GV of liquid minus GV of solid, and this will give rise to LV into delta T divided by Tm. Okay, I will explain the terms. LV is the latent heat of fusion per unit volume. Latent heat of fusion per unit volume, and delta T is the undercooling. That means T minus Tm, Tm minus Tt. This is equal to delta T, and Tm is the melting temperature. Okay, yeah, this is the equation that we got. So I will write this equation. I will consider this equation first now, and I will explain some terms. How this delta G depends on two things. Okay, so first of all, formation of solid, volume of solid that is formed, and the surface area. From this equation, it is clearly indicate that the volume that is formed, new volume that is formed by this solid, is having the positive effect, but it is subtracted, it is negative. So positive into negative, it is having negative effect. So formation of a new solid it has negative effect on the delta G. It will reduces the Gibbs free energy, right? So when we consider the surface area, there is A into delta S, A into gamma, it is having the positive effect. So overall, it is having negative effect. It is having positive effect on the Gibbs free energy. Change in the Gibbs free energy. Okay, so delta G is having these two effects. Then finally, we can write this equation as minus 4 by 3 pi r cube into delta GV plus 4 pi r square into gamma S. When we consider a new solid is a sphere, so we can consider different type of shapes. That is, we can consider trapezium, square, rectangle. The volume and as well as surface area will changes. That's it. So when we consider the sphere as our nucleus, new solid, this equation we will get. Okay, that is delta G equal to minus 4 by 3 pi r cube into delta GV plus 4 pi r square into gamma s. Okay, so now I am deriving the equation for critical radius. That is r star, right? Critical radius means that slope is 0. That is equals to 0. So differentiating this equation, equating it equals to 0, that we will get a critical radius. Okay. So after differentiating, so first of all I will write minus 4 by 3 pi as it is, r cube differentiation 3 into r square delta GV as it is plus 4 pi 2 into r to gamma s, that is equals to 0. Then we are shifting this term towards this side. We will get it as 4 pi 2r into gamma SL equal to 4 by 3 pi 3r square into delta GV. Okay, so this 4 pi and this 4 pi will get cancelled, and this r square and this r is get cancels. Then finally we are remaining with r dash equal to 2 gamma SL into these three get cancels and delta GV. Okay, this is the final expression, and it's most important expression, and in most of the interviews and in gate exams, questions will be asked on this expression. So what will be the critical radius if it is a sphere, and if they given the volume, Gibbs energy, change in the Gibbs energy per unit volume and the surface free energy, and we will get the r star, r dash. Okay, this is the most important expression. Okay, so now we got this expression and this expression. Now we need to determine the change in the Gibbs energy at this critical radius, that is delta G dash. So this can be obtained by substituting this r dash in this equation. Okay, whole cube this is square and delta GV. Okay, then here a lengthy equation will be there, expression will be there, by 8 gamma SL whole cube divided by delta GV square. This is direct square. I will cancel, and 4 pi. This is into 4 gamma SL whole square divided by delta GV. This is not delta GV. This is, sorry, interfacial is the right gamma SL. Okay, this is gamma SL will become cube. Then if we take the similar common term outside, that is 4 pi gamma SL cube divided by delta GV whole square outside 8 by 3 plus, sorry, this is minus, and this is 4, right? Am I correct? Yeah. So this will reduces to, so this is take the LCM and we will get it as 4 by 3, right? So after this final expression, delta G dash is equals to 4 into 4, 16 by 3 pi gamma SL cube divided by delta GV whole square. Okay, this is the expression that we got, final expression. Okay, now we will modify little bit these two expressions. Delta G dash equal to 16 pi by 3 gamma SL whole cube delta GV whole square. Okay, then R dash equal to 2 gamma SL into delta GV. This, as I said, these two expressions are very important as per the interviews, as well as per the interviews as well as gate exams. Now we are modifying, we are getting some parameters, measurable quantities. So we are converting this into some measurable quantities. Okay, so how this delta G star and R star will changes with respect to undercooling. Undercooling, that is delta T. Okay, so how this is, so in the previous slide we got this expression, delta GV is equals to latent heat into delta T divided by Tm. This is from previous slide. Just go back and just check this expression. Okay, so after substituting this expression in these two, we will get R star R dash as 2 gamma SL Tm divided by LV and 1 by delta T, whereas delta G dash is equals to 16 pi, sorry, this expression is little lengthy, I will write it as little bit downward. Yeah, expression G dash equal to 16 pi gamma SL whole cube Tm square 1 by delta T whole square. Okay, then from here this expression R star is inversely proportional to delta T and delta G dash is inversely proportional to delta T whole square. This is the expression that we got. This means R star, R dash and G delta G dash will decreases with increasing the delta T. I can write a conclusion. Both R dash and delta G dash will decreases with increasing undercooling. As we reduce the temperature more, the critical nucleus size will reduces. That means formation of the nucleus will increases. Tendency of formation of nucleus will increases. This is the most important thing I want to convey from this video lecture. Then we will move to the this expression, this graph. Okay, as I said, volume has negative effect, whereas surface energy area has positive effect on change in Gibbs free energy. When we are excess free energy, when we are shifting, when we are plotting a graph with this equation, so it is having positive effect. This is surface free energy, and whereas volume free energy has a negative effect. That's why we are plotting towards this side. So combining these two, we will get the change in the Gibbs energy as this line curve. So initially it goes on increases. After some time it reaches to critical value. Again it is decreases. In the next slide I will explain. So what is the importance of this curve? So if it is R, the formation of the R which is below this one, so what it is called clusters, and if the radius of nucleus is more than the critical radius, this is called a stable nucleus. So what is important, how it will be formed, I will explain in the next upcoming video. Thank you. Sorry, I will explain this a small concept in the this slide only, this video lecture, and I will move to the next nucleation. That will be a different concept, nucleation rate, and how the nucleation number of nucleus will be changes with respect to that of the undercooling as well as the Gibbs energy. I will explain the upcoming video. So as we know that if R dash, the nucleus that is formed in the liquid is having a radius R which is less than that of the critical radius, then the overall Gibbs energy can be reduced by dissolving the solid which is formed. That is called as a clusters. Okay, this is called clusters. If the radius is equals to the radius which is formed is equals to the r, r star or r dash, which is in equilibrium with the liquid. It is in equilibrium. Solid as well as liquid that is formed is in equilibrium. If it is r is greater than that of the critical radius, then the free energy can be reduced by growing this solid. Solid will grow and it will form a stable nucleus. Then the liquid will transform into the solid. That is, phase transformation starts to begin. That means necessary condition for the phase transformation, that is we should have the radius of a nucleus greater than that of the critical radius. So here the critical radius can be, if it is having more than this critical radius, Gibbs frequency goes on decreases, hence the stable nucleus will be formed and results in the decreasing the free energy, formation of the stable system. The system can be reduced its Gibbs energy by dissolving the radius. If it is having the nucleus, if a cluster is having a less radius than that of the critical radius. This is the importance of critical radius. That is given as I said, r, r dash equal to 2 gamma SL divided by delta GV, and G dash delta G dash equals to 16 pi by 3 gamma SL by whole cube divided by delta GV whole square. Okay, this is the main formula. Okay, thank you.